Okay, sorry about that. I was trying to tab back and I stopped the recording. So I'm just going to work through one of these parts as an example. When you do part A, you don't get any critical points. So I'm going to do part B because it's a little bit more complicated. So the f is 4x squared plus 5y squared. And the region is -1 less than or equal to x less than or equal to 1, -2 less than or equal to y less than or equal to 2. Okay, so all we're going to do is find the critical points, check the boundary, find the largest values, find the smallest values. So whenever we have one of these optimization problems, the first thing we check is when is the gradient, grad f, equal to 0. So my gradient is going to be 8x 10y, and I want that equal to 0, 0. And the only time I can have that happen is at the point 0, 0. So I need x equals 0 to make the first component 0, and I need y equals 0 to make the second component 0. This is easier than a lot of the critical point problems that we saw earlier in these sections. Then we ask ourselves, what about the boundary? And that's going to be these ranges kind of given to us for x and y. So for us, we're thinking about kind of this rectangle where x goes from -1 to 1 and y goes from -2 to 2. And inside the rectangle, we already checked that the only place where f kind of changes direction and might be a maximum or minimum is at 0, 0. But then we also want to check if x is bigger or smaller than that value on all the edges. So we're kind of looking at a cutout of a shape that might be like a bowl or something. So let's just go through the boundary kind of from left to right as I've written it here. So we're going to check x equal -1 first. When x is -1, f is going to be 4 times -1 squared plus 5y squared. So it's just going to be 4 plus 5y squared. Actually, I'll say. So the value of f is going to be larger if y is larger in magnitude. So y can be between -2 and 2. So if I do -2 or 2, I'm going to get the same y squared value 4. So it's going to be 4 plus 5 times 4 is just going to give me 24. And then this value is going to be as small as I can get it if y is 0. So when I plug in x equal to -1 and y equal to 0, I make 4 plus 5y squared as small as possible. It just becomes 4. And when I plug in x equals 1, I'm going to get the same f as I got when I plugged in x equal -1, since x is squared right here. So I'm just going to rewrite that if I do f of 1 and -2 for y, or 1 and +2 for y, I'm going to get 24. You could go ahead and check that for yourself if you wanted to. And if I have x at 1 and I plug in y equals 0, I'm going to get 4. So when I have y equal minus 2, f is going to be 4x squared plus 5 times minus 2 squared. So again, we're going to get minus 2 times minus 2 is positive 4 times 5 is 20. So we're just going to have 4x squared plus 20. So again, the larger x is in magnitude, whether it's positive or negative, the larger this f is going to be on this edge. And then if I take x to be 0, that's going to be the smallest I can get the value on this edge. So f of 1 minus 2 is going to be the same as f of 1, or minus 1 minus 2 is going to get me that 24 we already saw before. So since right now I'm looking at y equal minus 2, and I already looked along these two x edges, I'm just getting that exact same idea that these corners give me high values of f. And then when I go ahead and plug in x equal to 0, I'm going to get f of 0 minus 2 gives me 20. And plugging in y equal 2 gets me the same, because the minus 2 squared and 2 squared get you the same value. So we're going to have that f of 1, 2 is equal to f of 1, or minus 1, 2 is equal to 24. Same point we found before, just now it's this upper corner. And f of 0, 2 is going to give us 20. So at this point, we've kind of examined f on the four corners, as well as the edges when x or y is equal to 0. And we found that those are the places where on a single edge we can make f as large as possible or as small as possible. And then we also need to consider that we found the interior point 0, 0 could be a maximum or a minimum. And when we plug in f of 0, 0, we actually just get that that value is 0. So the largest possible value we found is 24, which we can get for those 2 points, as well as for those 2 points. And the smallest value we found on the edges was this f of minus 1, 0 gave us 4, or f of 1, 0 gave us that 4. But actually the smallest overall is that interior. When we plug in x and y equal to 0, we get 0. So the max is 24 at the points 1, 2, minus 1, 2, 1, minus 2, and minus 1, minus 2. And the min is 0 at the point 0, 0. And so the way this shape looks is that it's actually going to be kind of a bowl shape. So up in z, x, y, z. It's the smallest at 0, 0, and then it goes up. And it just so happens that you get the most increase if you're sitting at the edge of the corner of that rectangular region. And it's kind of like a little bit lower in the middles there, for example. But this part of drawing it isn't really needed to solve the problem. You just had to find all the points and evaluate them as we did down here.